Hey there, before we get started, if you would like to try out the bell ringer, you are welcome to. Just go ahead and pause the recording so that you can give it a try on your own. I would start off by checking to see if there's any factors of negative 14 that add up to positive 8. So we've got negative 1 times 14. There's not a lot of factors for 14. Negative 2 times 7. So that would give us positive 13 and positive 5. So we're going to struggle to find factors today. So moving from there, I would use the quadratic formula, or you guys can also complete the square, move the 14 to the other side and do the completing the square process. I'm going to use quadratic formula because I like it better. So your A value is 1, B is 8, and C is negative 14. We've got our formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oops, 2a. So if b is 8, then negative b is negative 8 plus or minus the square root b squared. So 8 squared minus 4 times 1 times negative 14 all over 2 times 1. Okay, so you can grab your calculators and simplify what's under the radical. We are going to get x equals negative 8 plus or minus 120. So that explains why we couldn't find any factors, because 120 is not a perfect square. And then 2 times 1 is 2. So you're going to check your perfect squares to see if there's anything we can do to reduce the 120. So we've got 4, 9, 16, 25, 36, 49, 64, 81, 100. You can go to the next one, it's 121, but that's over 120, so we can't use 121. So then you just start off by, you can do 120 divided by 4 gives you 30. So that means that 4 times 30 gives us 120. And if you check the other ones, so that's a good starting point. You can also just say, okay, do any perfect squares go into 30 to make that smaller? Or you can just check the rest of them. If you do 120 divided by 9, you get a decimal. So that one doesn't work. You also get a decimal of 16, 25, all of these. So none of these perfect squares are going to work. This is the only, 4 is the only one that works. So we're going to split 120 into the square root of 4 times the square root of 30. And then let's rewrite. So x equals negative 8 plus or minus. So the square root of 4 is 2. And then the square root of 30 is not rational. It doesn't simplify. So we just leave it under the radical divided by 2. So the only thing that we can do now is we can divide these two numbers by 2. We can simplify those. So we got x equals negative 8 divided by 2 is negative 4 plus or minus. 2 divided by 2 is 1. So we can either just, you can write 1 square root of 30, or you can just write the square root of 30. And those are your two solutions. That's it. Okay. So we are going over arithmetic of functions today. We are going to add, subtract, multiply, and divide functions, combine 2 or more functions to form a new function, and apply the arithmetic of functions to solve problems. 2 vocab words. We've got the commutative property, which is just saying it doesn't matter which direction you add or multiply numbers together. So you can see if we do 7 plus 4, we're going to get 11. And if we switch it around and do 4 plus 7, still getting 11. So that one works. Same thing with multiplying. If we do 7 times 3, we're going to get 21. And if we do 3 times 7, still going to get 21. 1 equals 21. Okay. A composite function is a function that's created by using the input of one function as the input of or the output of one function as the input of another. So an example is they're going to give you two functions, f of x and g of x. And they're going to say find we're going to use the composite function, which means f of g of x, which means that in the f function, wherever I see an x, I'm going to put the g function. So if we started off, the f function was 3x plus 1. So where I see the x, I'm going to put in 5x. I'm going to replace it with a 5x squared. And then you're just simplifying. So 3 times 5x squared, 15x squared. Plus 1, that wasn't affected, so stays plus 1. So that's a lot of what we're doing today. So here's your real world connection. Imagine that the band booster club at your school is planning a talent show. The goal is to raise enough funds to buy new uniforms. The ticket price for the show is $15, but there are costs involved too. The venue rental is $350, so there's your rental function. $350, and each chair costs $5 to rent. So what function represents? So here are our functions. Our ticket price is going to be 15x because maybe you're going to buy 3 tickets. So you do 15 times 3. Your rental function is the $350 plus $5 for every chair. So we have our 2 functions. If you call the total ticket sales f of x and the total rental cost g of x. So we did that. Then find the answer. Then to find the answer, you would just subtract your 2 functions. So f of x is 15x minus g of x. So that's a whole big function. So we're going to put it in parentheses because we want to subtract all of it. 5x plus 350. So what I'm going to show you later is this is technically a -1 outside of the parentheses. Anytime you have a minus sign outside of the parentheses, you want to distribute the negative sign. So it just makes everything on the inside. Minus 5x is minus 5x. Minus a positive 350 is minus 350. So we've got all of that now. We've distributed the minus sign. So I'm just going to put that 15x up front. The only thing you have to do now is combine like terms. So 15x's minus 5x's is going to give us 10x's and then minus 350. There's nothing else you can do. This equals our, I guess this would just be our total cost. There you go. It'd just be 10x minus 350. So that's all that's like the bulk of what we're doing today. Okay, so starting off with adding and subtracting functions. We just did a subtraction problem. So that's the whole process. So they're going to say, let f of x equal 3 plus 8x. G of x is 5x minus 2. Find f plus g of x. So you're adding the functions together. So we're going to do 3 plus 8x, that's your f function, plus 5x minus 2. Addition does not change any signs, so you don't need to use parentheses. You need to use parentheses when you subtract. Okay, so then we're just combining like terms. So we've got 3 and a -2, and we have 8x plus 5x. It does not matter which ones you put first. I like my x terms to go first, so I'm probably going to do those first. 8 plus 5, 13. So we have 13x. And then 3 minus 2. Our 3 minus 2 is just 1. That's a positive 1, so we're going to say plus 1. And then I'm just going to write f plus g of x equals 13x plus 1. You can just write 13x plus 1. Okay, so if at any time, remember, feel free to pause this video so that you can try the we and the you do. You can even pause to try the I do. That's totally fine. All right, so for the we do, you're still adding. So we're doing 3x plus 9 plus 5 minus 2x. Remember, when you're adding, you don't need parentheses because signs don't change. So I've got 3x minus 2x. That'll give us 1x, positive 1x. And then I've got 9 plus 5 gives us 14. That's all we're doing. All right, this would be a good time to pause if you want to try the you do. Again, just adding. This one looks extra crazy because they're squares. It's the same thing. You're just combining like terms. So we're going to do 6x squared plus 3x plus 1 plus 2x squared minus 9. So I start at the beginning, I go, okay, I have a 6x squared. Are there any other x squareds? Why, yes, there are. There's one right there. So I'm going to combine those. 6x squared plus 2x squared gives us 8x squared. Notice the exponents still stay the same. Then I'm going to go to the next one. All right, use my x squareds. Next one, 3x. Are there any other x terms? There are not. So I'm just going to bring that one down. So plus 3x. And then the last one, we'll just use blue again. Plus 1 minus 9. So 1 minus 9 is going to be negative 8. And again, if you're not sure, use your calculator. Put a box around it, you're done. All right, so subtracting. This is where you want to use those parentheses. So, and the order matters. They want the f function to go first. So you're doing 3x squared minus 2x, and then we're gonna go minus parentheses. Always use parentheses when you're subtracting because you're subtracting all of that. So minus 9x squared minus x plus 7. And we're going to distribute that minus sign because I like to get rid of my parentheses. So this becomes minus 9x squared minus a negative is plus, so plus x minus positive 7 minus. So it just changes all the signs to the opposites. So we've got 3x squared minus 2x up front, and now it's just combining like terms. So start with the first one. I have 3x squared. The next x squared is right here, so minus 9x squared. So you're just going to do 3 minus 9, get your negative 6, and it's still an x squared because we're not multiplying. That's the only time your exponents will change. So next one, I have a minus 2x and a plus x. So that's negative 2 plus 1 gives us negative 1. So we can just say minus x, or you can write minus 1x. The last thing is a minus 7. There's no like term, so we're just going to bring it down. The box around it, you're done. Okay. So again, go ahead and pause and work these problems out. All right, so again, f is first, so we put the f function first. So we have 5 plus 2x is our f of x function. We are subtracting, so we want parentheses. You can even write the parentheses around so you remind yourself what you're putting parentheses around. 6x minus 4. Distribute. So we have minus 6x plus 4. And then put the 5 plus 2x up front. And look for like terms. So again, I start at the beginning usually, so it doesn't matter what order your answer's in. Standard form is nice where the biggest exponents get brought down to the smallest ones. It doesn't matter though. So 5 plus 4 gives us 9. So that one's done. And then we have 2x minus 6x. So that is minus 4x. I'm going to leave it like that so there's no negative up front. That's nice. All right, the u-dos. So this is a plus and this is a minus. So again, good idea to pause right now if you want. Just kind of mixing in a plus sign here. So we have f plus g. So f goes first. So 6x squared plus 3x plus 1. It's a plus, so we don't need parentheses. 2x squared minus 9. Okay, combining like terms, we got 6x squared and a 2x squared makes an 8x squared. And then we already did this one on the last slide. So there we go. Have it again, I guess. Plus 3x and then minus 8. Yeah, we already did this one. Sorry about that. All right. Last you do minus. F goes first because it was written that way. Sometimes they'll switch it up and say, what's g minus f? And that's okay. So 7x squared minus x minus 1 minus parentheses. So we're subtracting g. 2x plus 1. Distribute the minus sign. So this is now minus 2x minus 1. And then just put the 7x squared minus x minus 1 up front. Combine like terms. So there are no other x squared terms, so we're just going to bring 7x squared down. We're done with that one. Now I have a minus x and a minus 2x. So that is -1 minus 2. So -1 minus 2 more is -3. And then we've got -1 minus 1 is -2. And you're done. Multiplying functions. So this is where exponents are going to change. So just a reminder, x times x is x squared. X squared times x to the 4th is x to the 6th. You add exponents when you multiply. Okay, so exponents get added. This is like 1 plus 1 is 2. This one was 2 plus 4 gives you 6. So that's a nice review for you. So f times g. So your f function, in this case, it's 5x, times your g function. We're just going to do parentheses, times x minus plus 1. So this is just a distribution problem. We're going to do 5x times x, and we're going to do 5x times 1. So 5x times x is going to give you 5x squared. And then 5x times 1 is just plus 5x. And you're done. That's all you got to do. All right, we do. That's still a times symbol. It's just bigger for some reason. No big deal. So f times g. So my f function looks crazy. We got the square root of x plus 3 times the square root of 2x. So radical rules say that if I have two separate things underneath two separate radicals, as long as they're both square roots or they're both cubed roots, you can multiply, you can add, like you can combine them still. So this is the same thing as the square root of x plus 3 times 2x. Let me just do that. It's a backwards distributive problem. It's okay. You're distributing all of this, and that's okay. Just don't throw the radical away. So square root 2x times x is 2x squared. 2x times 3 is 6x. So all you could do is do 3 times 2 is 6. You can leave it like that. It looks crazy. It looks like nothing you've ever done before. It's okay. You simplify it as much as you can, and that's all I'm asking you to do. All right, so for the you-dos, I would definitely recommend pause, try it, see how we do. This is going to be the FOIL method. You're going to see FOIL as an option. This stands for first, outside, inside, and last. You probably learned it in Algebra 1. It's the same thing as the distributive property. Okay, same thing as the double distributive property. So if you're thinking like, okay, I remember FOIL, but it was not as easy as just doing the distributive property, it's actually the same thing. So if you get an answer, you're like, oh, I just need to distribute, but maybe it's multiple choice and all you have for an option is FOIL. Just know that FOIL and distributive property, same thing. All right, so finding f times g of x. So f function is x plus 1. G function is x minus 1. So I'll walk you through the FOIL method. First is just the first terms in each parentheses. Outside terms are the end pieces. So that'd be O, but that's the distributive property. And then inside terms, and then the last terms of each parenthesis. Again, it's just the double distributive property. You'll combine the middle terms if possible, and then you're done. So we have x times x is x squared. X times -1 is minus 1x. We'll just put minus x. 1 times x is 1x, or just plus x. And then 1 times -1 is -1. Your middle terms are, in this case, your middle terms cancel. Negative x plus x is 0. So we've got x squared minus 1 left over. If you saw the pattern, we were like, oh, that's the difference of squares. You could have jumped to the end, but if not, no big deal. Works out in the end. All right, same thing, f times g. 2 minus 4x times 3 minus 4x. So double distributive or FOIL method. First terms, 2 times 3 is 6. Outside terms, 2 times -4 is -8x. Inside terms, -4x times 3 is -12x. And last terms, -4x times -4x. That'll be positive 16x squared. So this one's written a little backwards, and that's okay. Middle terms are what's going to combine. So we have 6, -8 minus 12. So that's like you owe $8, then you spend $12 more. Now you owe $20. So minus 20x plus 16x squared. And you're done. Okay, so for dividing functions, sometimes you have to factor and try to cancel as much stuff out as you can. So dividing functions, okay, so your f function divided by the g function. So we have f function is 4x plus 6. G function is 2x minus 10. All right. So I would start off by factoring out a greatest common factor if possible. So I can see that 4x plus 6, 4 doesn't go into 6, but 2 does. 2 goes into both of them. So you're left over with 2x plus 3. This 2 divided by 6 is 3. Oh, I'm sorry, 6 divided by 2 is 3. 4 divided by 2 is 2. So that's what's left over. And then on the bottom, it looks like I can take out a 2 again. And I'm left over with x minus 10 divided by 2 would be 5. Okay. The only thing we can do is cancel out those 2's because they equal 1. So that is your answer. 2x plus 3 divided by x minus 5, or over x minus 5. That's as simplified as it gets. So not so bad. And so that's just greatest common factor. So down here, you might be able to factor something a little bit more. I'm not sure. So we're just going to keep trying. So f divided by g. So we have 3x squared plus 7 divided by 4x minus 1. All right, let's see what we can do for this one. And we factor this one. No greatest common factor here. Next, um, next unit, we're going to be doing dividing polynomials like this in a different way, and you're not going to be tested on it until then. So let's just skip this one. We'll just skip. All right, up here, the u-dos, you've got, I'm just going to put the division bar right there. 6x, because it's f divided by g. So 6x minus 3 equals divided by 6x plus 9. Definitely some greatest common factors here. I can take out a 3 on top. So you've got 6 divided by 3 is 2x minus 1. And on the bottom, we can take out a 3 again. And we're going to get 2x plus 3. We can cancel the 3's and then you're done. So 2x minus 1 over 2x plus 3. All right, last one. This one looks a little factorable. I'm going to do the division bar right there, f divided by g. So I'm going to start by seeing if I can factor this top one. So I need factors of 2 that add to 3. How about 1 and 2? That works. So this one factors to x plus 1 times x plus 2. And on the bottom, this is the difference of perfect squares, which we did on the last slide. So this is going to be x plus 1 times x minus 1. Got one of each. The x plus 1's cancel. They divide out to 1. Anytime you divide something by itself, it's 1. It goes away, no matter what it is. So your answer here is just x plus 2 over x minus 1. And we're done. Composing functions. This one is a little different. Composing two functions means combining them into one function. So you're substituting one function into another. So this was our last objective that was written. So we've got this rule over here, and if you follow the highlighted parts, it kind of makes sense, but I know that it's a lot to kind of go through. So it looks like it's spelling the word fog. It's really just f of g of x. It's pretty similar to, it's kind of what we did in the real world example. So if you see fog, just know, oh, I have to compose functions. So these two things equal the same thing. So if you see it like this, it's the same thing as FOG of x. It's not really a letter O, it's a circle. Same thing though. So you are taking whatever the first thing that's listed, we're taking f, and we're going to insert the g function wherever I see an x. So here's your x in the f function. We're going to put 4x minus 1 in for that x. Okay, so here it is. Start out with 3x squared plus 7, and I replace that x with 4x minus 1, still squared. Then they expanded it because it was squared. So that's 4x minus 1 times 4x minus 1. It expands out to 16x squared minus 8x plus 1. There was still the 3 in front of it. So they distributed the 3 to get the next line. They distributed the 3 to get 48x squared minus 24x plus 3. And then there was still that plus 7 at the end. So they just did 3 plus 7 to get 10. And now it's done. Fog of x is 48x squared minus 24x plus 10. Okay, so let's try some simpler ones. So we've got f of g of x. So we're going to take our f function, and I'm going to replace that x with my g function, which is just x squared. So this one is going to be 7x. So we're just going to insert x squared. plus 3. It doesn't simplify to anything other than 7x squared plus 3. Okay. We replace an x with an x squared. So let's switch it around. What's g of x of g of x of x? So again, this is the same thing as g of f of x. So now you're taking your g function. So g of x was x squared. We're going to replace the x with 7x plus 3. So g of f. There we go. All right, so we're going to replace this x with our with our f function. So this is going to be parentheses, put in the 7x plus 3. Don't forget that that x was originally squared. I would like to say that you're done, but you should expand it. So this would be 7x plus 3 times 7x plus 3. So do the FOIL method or double distributive. 7 times 7 is 49, and that's an x squared. 7 times 3, 21, so plus 21x. 3 times 7x, another 21x. And 3 times 3 is 9. So the only thing you can do is combine those middle terms. So this equals 49x squared plus 42x plus 9. Definitely expand and multiply it out. Okay, so one more redo. Got a fraction going on here. Got a little reciprocal function. F of g of x. So f function first. We're going to take this function, 4x plus 3, and we're going to replace that x with a 1 over x. That's all you're doing. That's as good as it gets. You could rewrite it so it's 4 over x, because remember we could do 4 over 1 and just multiply straight across. So that could be simplified. Oops. 1 times it. So that's the most simplifying you could do. The box around it, you're done. All right, so for this you do, I'm not sure if we'll have enough space for it, but let me change colors just in case we can make this happen. All right, so f of g of x. So we're taking the f function, so 2 times x minus 4. I like to put it in parentheses, so it kind of like reminds me that I'm going to put that right there. So this is going to be 2 times x minus 1 minus 4. So distribute, and then minus 4. So we've got 2 times x is 2x. 2 times negative 1 is negative 2. And then minus 4. One more thing. You can do negative 2 minus 4. So that's 2x minus 6. There's your answer. If you switch it around, so it's g of f of x, starting with your g function, that is x minus 1. So this is what I'm replacing with f. So now I'm going to replace what's in parentheses with 2x minus 4 and then minus 1. There's nothing I can simplify in those parentheses. So if you want to rewrite it so that it says 2x minus 4 minus 1 without parentheses, you're definitely welcome to do that, or you can skip it. And then equals negative 4 minus 1 is negative 5. So we have 2x minus 5. We have enough room. Yay. So this is, again, this is just more of the same. So again, please feel free to pause at any time, give it a try. F goes first. So I have 3 times x, and I'm going to replace that x with a negative 6x, because that's my g function. And I'm just going to bring that 3 down and simplify. So 3 times negative 6, negative 18. X. Function has been composed. All right, f of g, so f is first. So I'm going to do 1 over x There's my f function. And I'm going to replace that x with all of this. This is going to be 1 over negative x plus 1. You don't really need the parentheses, so we can erase those. There is nothing we can do to simplify that, so put a box around it, you're done. Last one, g of f. So they're going to switch it up on you. Make sure that you start with the right thing. So we're starting with our g function. G is 3x squared, so I'm going to do x in parentheses and then square on the outside. And I'm going to replace it with x plus 1. So x plus 1, we bring the squared down, we bring the 3 down. You can expand this. I definitely recommend it. So this is going to be 3 times x plus 1 times x plus 1. This is the most work. I would save that 3 for last, because otherwise it's going to mess you up. X times x is x squared, so we'll just do this. X times 1 is 1x, so just plus x. 1 times x is x, so plus x again. 1 times 1 is 1 plus 1. And again, if you see what those we're going to combine to, you could skip it and just go right to the next line. So we've got 3 times x squared. X plus x is 2x. And then plus 1. The only thing left is to distribute that 3. So we'll do that. So we've got 3x squared plus 6x plus 3. And a box around it, you're done. I know that when you expand it, and when you have to expand and multiply it out, it takes a little bit longer. It looks like a few more steps. But remember, I'm showing you every single piece of work. So there are ways for you guys to make it shorter that work for you. It's just, you need to take control of that. All right. Have a great day. Go use these completed notes to try out your 3.5 quiz. And if you need help with anything, remember office hours are appointment only. So please send me an email so we can set that up for you. Have a wonderful rest of your day. And I'll see you next time. Bye, everybody.